Hello, young explorers. Today we are going to dive into the fascinating world of atoms. These tiny particles make up everything around us. What if I told you that our understanding of the structure of atom evolved through a series of groundbreaking discoveries, each one overturning the last? Let's explore how Thomson, Rutherford, and Bohr redefined the building blocks of the universe. Did you know atoms aren't solid little balls? But they are made of tiny particles with charges. First, we have electrons, which are negatively charged. Imagine them buzzing around the atom like bees around a hive. Then there are protons in the center of the atom, which have a positive charge. Finally, we have neutrons. These are also found in the center of the atom, but they don't have any charge at all. Together, these particles make up the atom. Let's meet the first model of the atom, proposed by J.J. Thomson. He imagined the atom like a Christmas pudding or a watermelon. The red part of the watermelon is the positive charge, and the seeds are the negatively charged electrons. In this model, the positive and negative charges balance each other, making the atom neutral. But this model wasn't perfect. Later experiments showed that the atom's positive charge is concentrated in a tiny space and is not widespread across the atom. Now comes Ernest Rutherford with his famous gold foil experiment. Rutherford used a very thin sheet of gold foil, just a few atoms thick. He directed the fast-moving particles called alpha particles, which are positively charged particles, at the gold foil. Around the foil, he placed a screen coated with a substance that would glow when hit by these alpha particles. According to the Thomson's model, Rutherford expected the alpha particles to pass straight through the foil with only minor deflections, because the positive charge in the atom was thought to be spread out evenly. But he observed something else. Most of the alpha particles went straight through the foil without any deflection. A small number of particles were deflected at small angles. Surprisingly, a very tiny fraction of the particles bounced back as if they had hit something very dense and hard. From his experiment, he concluded, most of the atom is empty space, allowing the alpha particles to pass through. The positive charge and most of the atom's mass are concentrated in a tiny, dense region called the nucleus. The nucleus is positively charged, which caused the repulsion and deflection of some alpha particles. This experiment completely changed the understanding of the atomic structure and led Rutherford to propose his nuclear model of the atom, where electrons orbit a dense nucleus. But there was a problem with Rutherford's model as well. Scientists realized that if electrons kept spinning like that, they would lose energy and crash into the nucleus. So Rutherford's model also needed an upgrade. Then came the next model proposed by Niels Bohr. Enter Niels Bohr, who fixed the problems in Rutherford's model. As per this model, electrons move around nucleus of an atom. But they move in discrete orbits. These orbits are called energy levels or shells. Different energy shells are K shell, L shell, M shell, and N shell. Each energy shells have different amount of electrons and different energy level. Example, K shell can hold less electrons and has less energy level than the L shell, and so on. While in these orbits, electrons don't lose energy, which keeps the atom stable. Bohr also explained how electrons jump between shells by absorbing or releasing energy. This is how atoms produce light. The Bohr model of the atom was an important step in understanding atoms, but it had some limitations. The Bohr model could only explain the structure and spectra of simple atoms like hydrogen, which has just one electron. The model didn't show the detailed structure of electron energy levels. Scientists later found that each level, like KL, M has smaller sublevels S, P, D, F. The Bohr model didn't explain why spectral lines split when atoms are placed in a magnetic field called the Zeeman effect or an electric field called the Stark effect. The model didn't explain how atoms bond with each other to form molecules. So students, with this we have successfully covered Thomson's, Rutherford's and Bohr's models of the atom in detail along with their drawbacks in this video. Hope you have understood the topics well. Thank you for watching.